Hello everybody, welcome. It's my pleasure to welcome you for our webinar today, which is part of Renci's Accelerating Collaborative Team Science webinar series, our ACTS series. My name is Chris Lenhart, and I am a research scientist here at Renci with an interest in how multidisciplinary teams use information technology to do what they do, particularly building cyber infrastructure. So I'm particularly interested in our topic today, and I'm very excited to have the opportunity to briefly introduce Dr. Jim Sporer, who will be talking. And before we get to that, I'm going to just run through a couple sort of agenda housekeeping items. What we'll be doing is introducing the speaker, and he'll have a chance to say a little bit more about what he's doing. Then we'll hear his talk and what he has to say about AI and team science interactions. And then the sort of fun part is we'll get to hear from you all out there in the audience. We'll do sort of a Q&A back and forth. And as you may have noted, we aren't going to be using Zoom Q&A for that purpose. Instead, we use this tool called Easy Retro, which we have shared the link in the Zoom chat. So if you have a question while we're going through all this, pop it onto the Easy Retro board. Hopefully you'll find it intuitive, easy to use. As I said, feel free to add things as we go along, and then we'll try to get to as many of those questions when we do the moderated part after the talk. So without further delay, let me turn it over to Dr. Sporer to please tell us a little bit more about yourself, and then we'll go from there.
Great. Thank you, Chris. I'm just going to share my screen and fire up some slides. So that's what I read on my, oops, that's the wrong one. This was my 50th reunion slide deck, and I was just showing it to Chris before the call. Let me get the right one here. Here we go. And I got to move a Zoom bar out of the way. And there's we go. Okay, great. And these slides are already online. As Chris said, I'm Jim Sporer. I'm a retired industry executive in IT. I've worked on AI, as you'll find out, all my life, practically. And it's a great pleasure to have this opportunity to talk to you a little bit about the role of AI as a team member in scientific research, and a little bit about the need for episodic memory and GTD, generate, test, and debug architectures to avoid hallucinations. I read a lot, so you'll see I put books everywhere that I like, and I encourage you to take a look at some of them if you're interested. And thank you, Jess, I saw you already put the slide link in. I just put it in as well for everyone in case you want to download. Feel free to use it. Steal the slides, reuse them. I'm retired. I've done it. I've had fun with them, and I hope you do as well. So, what I'd like to do today is I want to get into this role of AI as a team member in scientific research. And now that I've been retired for 3 years, one of the things I'm doing is building an AI digital twin of myself to give talks like this, based on my papers and other things I've written. But before getting into this AI as a teammate, I want to review a little bit of the history of artificial intelligence and some of the challenges of keeping up. The challenges I see 3 challenges, but a big challenge for teams is how do we keep up with accelerating change? And I personally believe that's going to be through the use of a digital twin to help us keep up with change. Our digital twin is going to be able to ingest far more information than we were able to do. So I'll speculate a little bit about how that will come to be. And please do post questions, comments as they occur to you. And I'm happy to follow up if I don't get to all of them during this talk. I love to, when I give talks, what I get out of it is all the questions. And so I'm happy to follow up later with responses as I have a chance to contemplate them. So I'm going to get into these 3 challenges to, I call it being comfortable with AI as a teammate. And I'm a little uncomfortable right now with AI as a teammate. The first reason is energy. These AI systems are consuming a huge amount of energy. And every time I use it, I think about, gosh, this isn't good for the environment. Um, and hallucinations. If a person did those things, we would call it delusional lying, where you sound very confident, but you're in error. And some people call it BSing. So we'll get into a little bit of that and how that might be mitigated. But last is responsibility. Who's accountable when things go wrong? And that'll be the topics for discussion. In preparation, I use generative AI every day. I usually have 4 tabs open in my browser with 4 different AI tools. And just before the talk, I decided to generate a little image for these from my abstracts. So that's the image that I got. Um, so let's look at the history a little bit. So I like to start the history with the Dartmouth's conference, the AI conference in 1956, workshop, I should say. Um, uh, this just coincidentally, 1956 was the year I was born. So I feel like my life and AI kind of parallel each other. We'll see some of those parallels as we go along. But certainly my previous employer, IBM, as well has its place in the history. Nathan Rochester, the person who developed the numeric processing units and CPUs for some of the earliest computers, was at this Dartmouth workshop. Also, Deep Blue, the IBM chess playing program, and Watson Jeopardy 2011. And if some of the investments that IBM is making pay off, you may see AI on a quantum computer in years ahead. But it's important to take a look at this history of AI. And again, I like to do it because if you look at the proposal that primarily John McCarthy authored, and by the way, when I got to IBM Research out here at Almaden, they told me there was a contractor from Stanford, an old professor who would be reporting as part of my team. So I was delighted when John McCarthy reported to me at IBM Research at Almaden when I took over that role years and years later. And of course, I had Minsky as a professor at MIT. But if you read through this 1955 proposal, and I don't know how many of you have, it's online and you can read it. It's very short. Really interesting to look at the budget they asked for, how tiny it was back then. But they talked about automatic computers, which were relatively new. How can computers be programmed to use language? Neural networks, and a theory of the size of calculations. And those 4 things, they thought they would make pretty good progress in just a few smart people together for a summer. But it wasn't until 2023 with OpenAI's GPT-4 technical release that I would say all of these goals were achieved. So if you look at what GPT-4 was able to do, all of the goals that they originally set out in that 1955 proposal were finally accomplished. Now, when I got to MIT, and again, Minsky was one of my professors there, um, giving lectures on AI. It was a pretty exciting time, but it was still early days of AI. And when I graduated from MIT, my first job was at a company, an AI company, AI startup, doing mathematical models of speech and language. Exxon acquired us. And I just want to say this was a really exciting time in my early career. So you can sort of see how AI kind of has been a factor in my early thinking, and fortunately able to make some nice contributions early on these mathematical models. But even then we knew, gosh, we don't have enough computing power. Gosh, we don't have enough data. So given that I knew it was going to be decades before we'd have enough computing power and data to really make a difference on these mathematical models of language and speech, I decided to get a PhD at Yale in computer science and artificial intelligence, and had the good fortune of working with a number of people there. Um, Elliot Soloway, Roger Shank, Drew McDermott, some of the pioneers in AI for education, in fact. And what we worked on, and we'll get to this, is the model I developed for student programming was based on a generate, test, and debug model, which I think is needed for dealing with hallucinations. So I'll get into that in a minute. But a lot of the work um, that we did at Verbex was more on the generative side and recognition side, but we could clearly see that if we didn't have a test and debug module, and that's what I worked on in Yale, we were going to have some problems. At Apple, I worked on AI in education. At IBM, I had a number of roles, including CTO of our venture capital group, had the good fortune to meet a lot of people and work on some team science oriented work, transdisciplinary thinking. IBM wanted to develop what we called service science to combine business and technology. And that's where I met Steve Fiore, who looped me into this exciting team science world. But when I retired, and since I've been retired, I've been mentoring students on using generative AI to build content, using generative AI to build digital twins, which I think are going to be essential for keeping up with accelerating change. And also now we're starting to work on building AI models, not just of individual people as digital twins, but whole organizations. And we're doing that especially for how we onboard volunteers and people into service roles in organizations, which I think is a big part of the future. So let's get back to these three challenges. So why am I a little uncomfortable with AI as a teammate? Again, it's this energy problem, hallucination problem, and responsibility problem. And I'll get into each of these three. But again, first, I really want to talk about a little bit about why teams. And the biggest challenge I think we have these days is keeping up with accelerating change. If you're on a team, the world is moving so fast in so many disciplines. The way I used to explain this at IBM is when I had a big budget, I would say, okay, research team, that's a great idea. Here's $1 million. Go off and solve it. And if at the end of that year, they're working on this problem, they spent $1 million, maybe they've solved the problem. But if somebody shows me there was a publication that they hadn't read at the very beginning, and if they had read that, they wouldn't have had to spend the $1 million, I wouldn't consider that a success. So really, we really, from an efficiency standpoint, we really have to be able to keep up with accelerating change, and that seems to just be getting harder and harder. So how do I try to keep up with accelerating change? And I think this is an important topic for all of you in the team science community is to develop habits and techniques for keeping up with accelerating change. Here's how I do it. I follow people. Just about everybody on this list I know, and some of them come out with daily reports, some of them weekly, some of them monthly. And when I see something I like in it, I let them know. And when I see something I don't like, I let them know. But really, it's following influencers. And I just want to pause here for a minute because a lot of young people come to me and say, "What should I do? What should I be? What's the future?" And I say to them, become an influencer, you know? Start researching an area that you're passionate about and publishing what you're learning and see if you can get some followers. Because no matter what you do in life, you're going to have to keep up with accelerating change. And these influencers are all people who are trying to keep up with accelerating change. If I just had to pick two, I'd pick these two neuron guys. The AI daily update on AI is fantastic. Ethan Mollick at UPenn at Wharton, he comes out weekly with an AI report that's really good. But find the people who are super learners and super sharers in the area that you're passionate about and learn to have the discipline to follow them. That's the best I've been able to come up with, and I'd love to see some comments or questions about other techniques for keeping up with accelerating change. I'll just give an example. Here's Ethan Mollick talking about how open source is about 1 year behind proprietary in one of his reports. Reid Hoffman, a venture capitalist, founder of LinkedIn, is another person I follow. He's building a great digital twin of himself. And if you haven't seen it, definitely check it out because it's great. You know, he's written books and his digital twin gives very articulate descriptions and summaries of his books to different types of audiences. And I think that's another reason we want digital twins is let's say I had to explain my work to a truck driver or I had to explain my work to a congressperson. I could do it, but it would be a lot of mental effort to try to figure out how to do that. Generative AI is very, very good at generating possibilities that I can just check. Um, Also, these humanoid robots are something that I'm following. One of the things I do with my influencers is I try to make sure I get oppositional influencers I follow. Like Matthew Berman is very, very positive about AI. Gary Marcus is quite negative at times about the current state of AI. But occasionally they agree. They did when this GPT 4.0 was introduced, and I find that interesting. So find your influencers that you can follow to keep up with accelerating change and try to find a diversity. I think that's the best advice I have there. Now I'm going to get into why I think the future of AI teammates isn't just like, oh, the AI over there that's on our team. No, I think the future, there will be that, but the future is more your AI, your digital twin is interacting with the digital twins of others on your team. And I want to explore that a little bit in the upcoming slides, but I just want to see if that's clear to you all that it's not like this galactic AI super intelligence over there in the cloud. The way I think it's going to go is more there will be some of that, but it's more I want to interact with Chris. So if I have an AI model of Chris and Chris is able to access my AI model of me, our AI models can explore communicating with each other in a much faster way than either Chris or I could do, even if we had hundreds or thousands of conversations. And that exploration of possible conversations that Chris and I might have is something our digital twins will help us with. And that's how I really see it going more is it's going to be a digital twin of us. And here's my prototype digital twin. I've got them on my YouTube channel. You can go out. The great thing about my digital twin is, I speak a little bit of French, but my digital twin really can speak French and Chinese and Japanese and German. So I would say my digital twin is a little bit better communicator than I across languages. My wife saw it and she said, "Gosh, it seems a little smarter than you, but a little bit emotionally blunted." So there will be progress in these AI digital twins. So let's get to these three challenges. I just briefly want to talk about energy because every single time and I use AI many, many times during the day, I'm in the back of my mind, I'm uncomfortable thinking, gosh, I'm just using energy, using energy, using energy. So what are we going to do about energy? Well, one thing is AI to help us with climate change. And I think there's going to be a lot of team science discoveries using AI to come up with new materials and new methods for energy. So that's great. But decarbonization of our energy system is going to be needed, and that's a huge investment that's required. And a lot of these things are huge investments that are required. And again, a lot of computer scientists are breaking down generative AI's hefty carbon footprint. And you're starting to see lots of articles about, as more people are using this generative AI and bigger systems, and the vendors are competing for us to use their tools and not the competitors, we're using lots and lots of energy. And we got to figure out a solution to this energy problem, or I'm not going to be as comfortable using AI as I might otherwise be. I love this quote: "Using AI to summarize an email is like getting a Lamborghini to deliver a pizza." It's just, we really have to do something with energy. And again, to kind of plug my former employer, IBM has the North Pole chip. So this is something we take very, very seriously at IBM. And Dharmendra Mota at the Almaden Research Center is doing great work with his team to create low energy um, versions for AI, hundreds of times, thousands of times less energy use. And that's what's going to get me comfortable on the energy level when we can get down to lower energy levels. Now let's talk about hallucinations, the other thing that is a big problem. Um, again, if a person did this, we would call it delusional lying, sounding very confident as you're making an error, um, or BSing. And just for amusement, I put in this link to this great paper by Hicks and his colleagues on ChatGPT is bullshit. I urge you to read that if you haven't, because it's just a fun read and it's also right on the money about this problem. But how are we going to address it? I believe we're going to need two things. We're going to need a generate, test, and debug architecture, and we're going to need episodic memory systems. So let me just maybe in a couple minutes here try to give you a sense of what we've got going on here. So generate, test, and debug, the LLMs, the large language models, we've gotten really good at generate. We can generate things that read very well. And if you think of generating not just one answer to your prompt, but imagine generating 10 answers. I usually keep four LLMs open on my browser and just I type the prompt into one and cut and paste it into the next and cut and paste it into the next, cut and paste it into the next. So I'm using four LLMs. By the time I hit that fourth one in, I go back and I've got my answer to it, and then I can compare them all and look for, hallucinations or where they're similar. But imagine generating 10 or 100 or 1,000 answers to every prompt you generate. Now, some of them are going to be better, some of them are going to be worse. How do you know? You're going to have a test. And for those who've been following Strawberry and the latest OpenAI stuff, basically that's one of the approach they're taking is they take multiple generations and they find tests, because you can do a test and see, oh, this one's got a problem, this one's got a problem, this one's got a problem. Now, when you test and you find a problem, what do? Well, you could just throw it away. Say that one's no good. Or you can go into a debug mode. And when I was at Yale working with Elliot Soloway, we did protocol data of students learning to program, and we studied their generate phase, their test phase, and their debug phase. I realize it's a little bit dated research, but this generate, test, and debug architecture looks very cognitively plausible, what we do, and it does look like the direction some of the vendors are going. Now, if you want a more recent paper that gets into some of this, I would recommend this paper that one of the people I follow, Ross Dawson, he's down in Australia. He found this paper, and I started going back and forth with him about generate, test, and debug architectures. So if you follow Ross, you might be able to see some more of this thread on generate, test, and debug models, but this is a good paper as well. So anyway, I just want to give you that intuitive idea that if we're going to beat hallucinations, we're going to have to over-generate possibilities, and we're going to have to filter them, test them, and in some cases, we're going to have to invest in debugging them. Now, let's talk a little bit about episodic memory and what do I mean by that. This is a model that I published about, I don't know, maybe a decade ago, where I was working with Don Norman. Some of you may know him in the HCI world and design world, and Paul Maglio. And we were brainstorming one day in my office at IBM Almaden Research, and we were trying to think about what the right progression is for thinking about AI. This was, like I say, a decade or so ago, I think after Watson Jeopardy or something. And we came up with this model of a tool, an assistant, a collaborator, a coach, and a mediator. And the types of models that they would need to do a good job at all of these things. The mediator being a trusted mediator that you trust. Imagine an AI that you trust to do things on your behalf. Like for me, I trust my wife. She's a lawyer, and sometimes when I've got something complex to do, I'll say, Diane, you take care of it. You're better at this than I am. And I trust her. And I know she has the skills to negotiate things on my behalf better than I can do for myself. So imagine someday there's an AI that's out there looking out for you and able to negotiate things legally on your behalf. You're setting up a trust for your family if you're gray hair like me, and you trust your cognitive mediator to run the trust for you after you're gone. That's the ultimate system, but that needs models of institutional models, trust, and social acts. But there's this also, who are you interacting with? And you have to have an episodic memory of those interactions with other people. If you think about team science, you wouldn't want an AI that each time it starts, it's like, who are you? Who are you? Who are you? you wanted to know the history of interactions that you've had and build on those interactions. So that's where the episodic memory comes in. And there's some other things as well. I don't have time. I've written some papers on this that zero in on this, but this is how I think we get to intelligence augmentation in a human-friendly way. And a really big, it's in small print over here, but as we get more and more dependent on AI, I'm reminded of something Steve Jobs told me at Apple when I was working there, and Alan Kay, the inventor of the personal computer when he was at Apple and I was there. And both of them had this idea that as we develop these advanced technologies, they should be bicycles for the mind. And I would say the first time I was in a meeting and one of them said that, I said, why don't we want a car for the mind? A car goes much faster. And I was corrected, and they said, no, we want a bicycle because when you're in a car, it makes you weaker for walking. A bicycle makes you stronger for walking. We want technologies that are going to make humanity stronger, even if we take away the technology. And I think that's a very important lesson that I learned and that we need to constantly remind ourselves as we build these intelligence augmentation systems. Are they making us stronger if we take them away? Then we're probably going in the right direction. Do they make us weaker if you take them away? Then we're probably going in the wrong direction. So at the end of the day, um, episodic memory is really an accurate version of history on which individual identity is based and predictions of future interaction behavior can be made, which is the foundation of trust. Chris, if I can predict you reliably collaborating in a healthy and mutually beneficial way, I would trust you. If I didn't, if I wasn't able to make those predictions, I would have less trust. So we have to think about episodic memory and how we record history. And of course, this gets into privacy issues and auditability issues. There's a whole host of issues we looked at IBM around this and other places. And for GTD, we have to look at the relative energy cost of generate phase, test phase, and debug phases and exploring beneficial and risky possibilities in different realms. There's different types of truth. And if you haven't read this book, The Unaccountability Machine, I really urge you to read it because it seems like there's an evolution in our complex systems, especially as we inject more technology for avoiding accountability and responsibility. That's really alarming. So I'm going to wrap up with some final thoughts. Let me see how I'm doing on time here because I can skip all this. Yeah, I think I got about 5 more minutes. I can get through this in 5 minutes. So I want to cover just some final thoughts for you all because we've touched a little bit on these three things: energy, hallucinations, and responsibility that I want to see advances in an AI before I'm really comfortable having them as an AI teammate. But there are some other things that we have to keep in mind as well. This is an important chart. This is my version of Moore's Law. And you can see $1 trillion, $1 billion, $1 million, $1,000, and $1. I'm old enough, I was born in 1956, that I've experienced this up to this point where every 20 years we get about a factor of 1 million reduction in the cost of computing. And so if you look at the years, 1960, 1980, these are every 20 years. I'm 68 now. Maybe I'll make it to 80 someday. If I'm really lucky, maybe I'll make it to 100. But what we can see here on these diagonals is the amount of computation. Our human brain is estimated at an exascale, which is 1 billion instructions per second. We can see that about 2060, we get to an exascale at $1,000. So when people ask me, when will we really have AI totally transform the economy? Probably by 2060, I would say. And you can see what happens here as the cost of computing drops. We're getting GDP per employee trend going up and up and up. And this is why I'm very interested in a digital twin of myself and digital twins of whole organizations to think about the productivity gains that we're going to get from AI in the future. Now, this guy, I'm sure many of you recognize him. He's Jensen Huang. He's the CEO of NVIDIA, man of the hour. And I love this. He was at Stanford a couple months ago giving a talk where he said, if you can imagine a tiny chip, his H100 weighs 70 pounds, 35,000 parts, $250,000 in cost, and in his talk he said it replaces a data center full of computers and cables. In fact, he says the cost of the cables alone that the H100 replaces is more than $250,000. So why, if you're running a data center, why wouldn't you buy this chip? And as he's driving the marginal cost of computing to zero, and again, the marginal cost of computing is you can look at any object in the world or any service in the world and say, how much of the cost of that is labor? How much of the cost of that is material? How much of the cost of that is energy? So he's talking about how much of the cost of that is computing. And more of our services depend on computing. So as he drives the marginal cost of computing to zero, the demand for new service offerings based on computing is going to go through the roof. And this is the mindset we need, I think, for thinking about the future as NVIDIA and others drive the marginal cost of computing to zero. And who knows, IBM may get the AI running on quantum computers. I would love to see the team science of room temperature superconductors take off, because I think that would be really a great way to revolutionize a lot of things around energy. Um, but we have to learn to invest wisely to get these things. And as responsible actors, we have to get better at learning to invest and becoming better future version of ourselves. These are a couple books I recommend. This one I wrote with some colleagues a couple of years ago, and here's the Don Norman book that he sent me a couple of years ago, I guess, to read, that I thought was really good. Um, and again, from a team science perspective, I think this notion of the T-shaped individual, that we need breadth and depth, and we have to become more transdisciplinary. I'm not going to go into it, but I've given a lot of thought and written a number of papers, even co-authored a couple books on this transdisciplinary notion of how do we do a humanity-centered harmonization of all the disciplines to really get us to the point where we can accelerate our learning in a very, very productive way, and we can accelerate our ability to collaborate in a very productive way. Um, and one thing I'm playing around with these days, if you're wondering what new thing I'm playing around with, I'm just looking at our communication bottlenecks and the speed at which we can speak, the speed at which we can write, the speed at which we can read, and trying to think about how AI could potentially make us 640 times faster if we can get all of these effects to harmonize. I won't go into service science, but that's one of the things I've worked on quite a bit, in addition to artificial intelligence. But I'd just say that artificial intelligence is primarily about automation and generation of smart machines, but the service science work I did for IBM was more about how we transform as individuals and as organizations. So it's about generations of people that are more capable. And this was the phone that was on the wall in the farmhouse in Maine where I was born. Yes, it was made of wood. It was called a party line. This is the phone that was in my MIT dorm room. Some of you may remember the dialing. Some people today don't know how to use those. This was my first mobile phone when I got to Silicon Valley. This is, of course, what I have today, my iPhone. What will I have if I'm lucky enough to get to my 80s in 2035? And if I'm super lucky, make it to 100, what will I have by 2055? Those are the kinds of things I'll just leave you with as I end my talk. And if people ask me what I think the most important skill is it programming? Is it, what is it? I would say self-control. I think this is the thing that more important maybe than intelligence in determining the success of people. And if you're interested, here's a paper and here's a book that kind of go into this topic. And with that, I will end and see if there's some questions. So,
You
Chris?
bet. There are questions. And wow, thank you. This was really, really, really interesting. Before we get to the questions, let's just do a quick recap of the retro board. But thank you, Dr. Sport. That was fascinating. So I think Amanda's going to walk us through that.
Yeah, absolutely. So once you have the Easy Retro board open, you are simply going to click on the plus sign in the relevant column, type your idea, And when you're finished, hit the blue box with a thin white check mark and save within the field. You can then see your idea appear on the screen for the public's reaction. You can also upvote someone else's idea using the thumbs up icon and comment on another idea using the quote bubble icon. So we have some great ideas that are going to get us started here, but feel free to react to other comments and upvote them as well.
Awesome. Thank you, Amanda. So let's see, I'm looking over the questions and there's so many interesting issues you've raised, Jim. I want to maybe try to synthesize some of the questions I'm seeing on the retro board. And I'll say in advance apologies to any of you if I'm paying short shrift to what you were after in your question. But the way I want to synthesize is a lot of what you were talking about is very sort of future and somewhat theoretical. A lot of the interest around team science is sort of in the practical applications of something like AI. And I know you talked about AI as a teammate, but maybe could you spin a little bit more on some of the practical uses of AI that teams might have? And I think those would fall into two broad categories. One would be, the so-called task work, the actual project work, and then there's the teamwork, which is how you get along and schedule things and do your notes and things like that. So there's a lot of potential for AI to help both, but in a more practical sense, how do you see that playing out in the context of science teams?
Yeah, yeah. So let me talk about the practical stuff because I use these tools every day in a practical sense. Probably the best use that I find is summarization. I think the summarizations are very, very good. This is part of keeping up with accelerated change. People are sending, I probably received 4 80-page documents just today in my email. And, uploading those and getting a summary often is better than reading the abstract. But summarization is a very, very practical thing that I find these tools are very good for. Um, Another thing, and again, I usually keep 4 of the tools open simultaneously because I want to compare them. But another practical thing besides summarization is I use them for programming. So I don't know how many of you have to write little glue code Python programs to do little things to accelerate your workflows, but I find that the generative AI is very, very good at writing small little Python programs. Maybe I've got to map some stuff in a spreadsheet into a HTML format or something. So glue code, that's something else I use pretty much on a daily basis, little bits of program code. Um, the other thing that I'll do, and this may sound like you know, a simple thing, but it's surprising how often I use it, is sometimes somebody will send you an email or you have to do something, but you're delaying it, you're procrastinating answering the email, or you're procrastinating getting started on a project. It's human nature, I guess, sometimes to procrastinate. I find the LLMs are super at anti-procrastination. I can pop it in, and even if it comes up with a crazy answer, at least it gets my momentum going that, okay, that's crazy. I know what I need to say now. Or in responding to an email, or, wow, this thing that I had been putting off, now I've got some additional ideas here, and I can lean into it a little bit more. So I would say summarization, um, uh, glue code, and anti-procrastination are very practical in my life. And those are things I use every single day this for. I also like to and I've written a couple papers and chapters on the use of these tools for when you have to communicate um, to a novel audience that you haven't communicated to. You can take, your paper or a description of your abstract and say, I want to explain this to, you know, The classic example people use is a 5-year-old, an expert in the field. But, you can also tune it to, I've got to give a talk to a group of management of information systems people, or I got to give a talk to a group of team science people. And just doing that and reading some of the advice is really helpful. It's very, very practical. Um, One other use that I haven't made use of, but I'm blanking on the person's name. It was just right on the tip of my tongue and I lost it. But he was talking about when there's a conflict that's arising. Let's say you're in a meeting and I'm advocating one way and somebody else is advocating another way, and we're kind of getting hot under the collar a little bit, because, no, you're not listening. My way's better. No, you're not listening. My way's better. There is an opportunity to have both parties use generative AI to explain their approach in a different way to the other person. Please explain this model to a person who thinks this model's better. And it diffuses the conflict because, now you're both looking at what the AI has generated and not like angry at each other or emotionally over invested in your model versus theirs. So I haven't done that yet, but I've heard about that. And I have to say that sounds like a very, very practical team sciencey thing that next time you're in a meeting where two people are a little hot under the collar, maybe you can defuse it using that approach.
You can blame AI then, right? You don't have to blame the other person, but yeah. How about just a little bit more the AI for the challenges of shared cognition? I mean, I think you alluded to this a bit. So across a multidisciplinary team, that part of the challenge is, creating that shared understanding of what it is you're doing, plus the synthesis, the benefits of teaming is the synthesis and creation of new knowledge, new ideas. So how can AI or these digital twins, what would you foresee them helping in those regards?
Say that again. I missed the very first part.
So what I was saying is the stuff you just outlined was very sort of practical in the sense of the summarizing and setting up understanding to-do lists and things like that. But how about on the challenges of teams of shared cognition, creating that common understanding of what it is you're doing, as well as the synthetic benefits of teaming to create new ideas and new knowledge. What can AI do in those contexts?
Yeah,
Make
that's a
sense?
great. Yeah, that makes sense. Perfect sense. I would say I don't really have any good ideas there, but I would love to hear other people's ideas there because um, let me give you an example. I was mentoring some students from Penn State University earlier today who are working on this model of this nonprofit organization. And I was telling them, we've had many volunteers come through this nonprofit over the years, and each volunteer tries to do a good job of documenting their role, what they did. But, as I look at the mass of accumulated documentation on our volunteer roles, it's all over the map. There's no standard format. It's all over the place. A lot of it's out of date. We maybe changed a tool. It's just I said it's and sadly, a lot of it's just a pile of junk now. Even though when it was done to try to create this common understanding of how this role interacts in the whole organization. So that is, I don't, that's such a great question. It's in some ways it's the most fundamentally important question is how do we create a shared mental model that we're all on the same page and we're able to communicate with each other much, much more rapidly. And I'm kind of the mind that changing our wetware in our individual minds, especially in a rapidly changing world, is very, very hard. So we kind of have to augment ourselves with a digital twin to begin to approach that, which I know is more abstract and theoretical and future oriented. But yeah, I don't really have a good answer to that one.
Well, I mean, my sense was the digital twins talking to one another
Mm-hmm.
would be where that might take place. And you could almost envision a shadow team of these digital twins getting together and doing all the work. And I guess the question would be, well, then how do you get the content out of that back to to the real world.
Yeah. Okay, that I think is probably much simpler. And think of it this way. Think of it in the context of a student who has to interview for a job at IBM. So we take the student, we got a model of the student, digital twin of the student, and let's say I'm going to be the proxy IBMer that's going to interview them for a job at IBM. And I've done this hundreds and hundreds and hundreds of times in my career. So when a student interviews, usually they don't understand IBM well enough to properly interview for the job. So I have to say, you need to really understand these how IBM works before you can, pitch yourself in a compelling way. And then I have to say, and you've done all this great programming, but you don't have a GitHub account. And hiring managers, we do a lot of open source stuff, and so we like to see that people know how to use GitHub. So if you're doing programming, where's your GitHub? So I have, and then I look at their LinkedIn and I say, okay, you've got no certifications of any of the relevant IBM stuff in this area of data science. So boom, 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 I have these things programmed that I can do. Now I'm actually working with one startup company in Atlanta that they call it latent questions. There's a student, he's afraid to ask me a question because he's going to look stupid. And so his digital twin can get together with my digital twin and ask, or he can ask my digital twin those questions and not feel stupid. And then he can get the answer, and then he can improve his performance. Or he could just, we could run the digital twins to do 1,000 interviews and show me the best interviews that Jim wanted to hire me in, and pull out those features. So yeah, absolutely. This is where I see the future of communication is going to be our digital twins having thousands or millions of conversations and a selection criteria that's win-win. That's what service science is all about, is win-win productive interactions. So when we can generate thousands or millions or billions of conversations as a rehearsal, and we can filter down into just a few that we watch before we go in and do the real thing, that's going to be the power of future communication. We're going to be much better at communicating with each other. In fact, we may say that one. We may both be so busy that we say, let's not have the real thing. I'm going to hire you because of
Nice.
that one.
Because of your digital twin. Interesting. That raises all kinds of interesting questions. So I want to switch gears a little bit and go down the sort of pathway of the pain points and drawbacks. And I think in a number of the questions, there's a common theme around sort of data, the data that goes into creating the various models and whatnot. You have the challenge of proprietary data that's behind these, you know, bringing your own data to the field. You have the challenge of bad data helping to lead to the hallucinations potentially. You have now the potential for AI generated data to be fed back into AI models, which could create its own realm of challenges. So that's not really a question, but I wonder if you have any sort of reactions to all those challenges in this context, data related.
Yeah, I agree. Data is, what it comes down to. And we certainly saw that, when we were doing the startup back in the 70s and early 80s, that we didn't have enough data. Uh, I, you know, this is a really interesting thing, because if we live in a world of trust, we're willing to share more data. If we live in a world where there's little trust, we're not willing to share more data. So I kind of believe, this gets into the bigger issues of um, the social restructuring that's going to have to happen if we, want to avoid some of the really, really bad future scenarios. And somehow we have to learn how to invest to get a shared future that we all would want to live in, rather than the alternatives. So I would just say the answer to this one is one of the books I had on my list. It's called uh, Humankind, A Hopeful History by Rutger Bregman. He's a Dutch historian, and he looks at the models that we have of each other and the psychological, sociological, economic research behind these different models of people, and looks at them across cultures, across history, and um, it's clear we can create better cultures of trust than we have right now. And 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 once we have those, I think some of this data sharing stuff gets a lot easier. It's kind of like, and I could reference all kinds of stuff, but I won't because I'm so apolitical. But there's if your goal is dominance, trust isn't so good. But if your goal is get better together, then trust accelerates. I'm thinking of, like, when I was learning how to play chess and I would play a chess game and I would lose, the chess ladder and the chess ranking was used to put you in a competition pool in a swim lane where there were people roughly of your same caliber so that you would sometimes be learning and sometimes be teaching. You wouldn't be playing somebody super better than you or somebody super worse than you. And we all got better because we were all staying sort of in the Vygotsky zone of proximal development. We were suitably challenged and not bored. So this is a lot of what some people look at in service science is how do we design these cultures that are more, and use game theory to get us into this culture where competition is more seen as a positive thing and less as a dominance thing where we're going to enforce solutions on other people. And I mean, there's all kinds of literature on this. Kaldor Hicks economics, from the economics perspective. If somebody gets harmed, how do you compensate them? This unaccountability machine book that I just read. Again, I don't think I've got a good answer here, but I'm just saying, great question. Certainly am interested in good answers to this question. If other people want to share them with me, things to read, I'd be happy to read them. But yeah, that's the best I got on that.
Yeah, no, I mean, again, there are no easy answers here, and these are just the challenges we're dealing with these days in this context. So I would like to turn to a slightly different context, which is bringing back into sort of the academic realm. And we have a question that says, in the context of transdisciplinarity in science and research, how do you see higher education catching up to solving for increasingly complex problems in the midst of accelerating change?
Yeah. So for over 5 years, I led IBM's global university programs and traveled to 45 countries around the world, meeting with university presidents and deans and looking at this transdisciplinary problem and the future evolution of universities. And what I came away with is, if you look at the university as teaching, that's being transformed. If you look at the university in terms of research, and that's certainly team science related, that's being transformed. But there's this third role of the university, which I think the answer lies, and that's the startup venture area. And you can look at the Stanfords and the MITs of the world, but I do think that there's this actual doing part of the university that is going to get easier in the AI era. You know, if I asked you the question, is it getting harder or easier to keep up with change? Most people will say, oh, it's getting harder. If I ask you the question, is it getting easier, more costly? Is it getting less costly or more costly to do a startup? Most people would say less costly. And I think that's true. I think it's getting easier to do startups than it was. And certainly when each of us has 100 digital workers working for us, and there's the data science expert, and there's the programming expert, and there's the marketing expert, getting to do a startup is getting easier and easier. So I think the future of the university is to lean in to that third leg of the stool, the startup leg. And I remember there was this one university in Sweden where they were toying with the idea that no student can graduate until they've done a startup. And I said, 100% behind you on that one. That is fantastic. And it doesn't have to be a tech startup. It can be any kind of startup, but they just have to have that experience of running a business. And I think that's the future of the university. Is its relevance increases to the degree that it's not only where people go to learn and maybe meet their mate. That's another university function, I think. And to push knowledge forward, but then to apply that knowledge in the world to make an impact. That's the university, is this melting pot, transdisciplinary melting pot that's really having a bigger impact. So yeah, I think the future of the university is very bright. I know people, journalists like to, oh, this university closed, this university closed. Yeah, there's some universities that are closing, but I think the universities that are tied to a city, and a city that's transforming itself into a future version of that city. This is where on my slide, I talked about responsible actors. And if you get into service science, a person is a service system. We give, get, and service. Business is a service system. It gives, gets, service. A nation is a service system. It gets, gives, service. So if we see the world as an ecology, an evolving ecology of service system entities learning to invest and becoming better future versions of themselves with more win-win interactions, that's where I see it going. And if people want that vision, they can read that book, Non-Zero, The Logic of Human Destiny by Robert Wright. That was in my list of books. But yeah, I think the future of the university is bright, because we need a world of young people who have in their mind, I'm going to make a job, not take a job. I'm going to make a job, not take a job. I was in a meeting at IBM. I looked around the room. It was a big meeting. Our future CEO, Ginny Rometty, was there back in the day, way back in the day. I looked around the room and I go, wait a minute. Except for Ginny Rometty and me, I don't think anybody in this room interviewed for a job at IBM. And so I raised my hand and said, I just made an observation that I think is kind of interesting. Did any of you interview for a job at IBM? And Jenny raises her hand and I raise my hand and nobody else raises their hand. And the reason was because everybody else came in through acquisitions. We acquired their companies. And so this concept of make a job, not take a job, this is why I encourage people to be influencers, students, become an influencer on something you're passionate about, because that's what's going to get you hired. And if you're thinking about it as like, I'm an influencer leading towards a startup company on something I'm passionate about, even if you don't start that company, you're going to be much, much more interesting to the person who wants to hire you, because they're going to be kind of like acquiring all that knowledge to bring into maybe a project in their company that they're going to do. So,
or you could just acquire their digital twin. But anyway,
Well,
I don't mean to cut you off, Jim, but we are running out of time, and I hope folks feel free to reach out to you. I believe that's okay. There's a lot more really interesting questions that we didn't have time to get to, some very technical, that you probably are very qualified to answer. For example, one about how do you create the automated test that's immune to hallucinations, just to prime that pump. But again, thank you very much for a very interesting presentation and talk and conversation. I'd like to share a couple